Hello and welcome. In this video, I'll walk you through the step-by-step process to completing your culminating activity. This is designed for the Grade 12 Advanced Functions MHF4U. The goal of this activity is to use your knowledge of advanced functions and an online graphing calculator to create an animated design. This activity consists of two parts. Part 1, create, part 2, analyze. This is an open-ended task where you can use your imagination to create a design that is meaningful, relatable, and relevant to you. You may want to find inspiration in one of the following. Your hobbies. This can be an activity, an object, theme parks, etc. The indigenous peoples. There is so much to choose from: the art, the culture, the history. Culturally relevant to Canadians. It can be an object, it can be architecture, our beautiful landscape. And in part 2, you have to analyze some of the functions as specified in the summary table, which is included in this document. What is expected of your design? Well, it must be unique and it must be your own work, and that goes without saying. And your design must incorporate a minimum of 10 functions. 5 of the functions will come from the group of the basic functions, and the other 5 must come from the group of the compound and composite functions. The list of basic functions that must be included in your design are a polynomial function, degree 3 or higher, which means no first or second degree polynomials, so no linear or quadratic functions, an exponential, a logarithmic, a trigonometric, and a rational function. The list of compound and composite functions consists of the sum, the difference, a product, quotient, and composite of two functions. Please bear in mind that when you add a polynomial to a rational function, it simplifies to a rational function. Or in other words, it simplifies to one of the basic functions. In this case, the combination of a polynomial and a rational functions cannot be considered as a combination of functions. So for combinations, you would want to use examples such as a trig with a rational, a polynomial with an exponential, a trig with an exponential, etc. The list of equations that are not allowed in your design is quite short. Firstly, the linear and quadratic, which I discussed, and the absolute value functions. Also, in your design, you cannot include circles, and if you want to include a circular shape in your design, you may use polynomial functions and their transformations. Now, what are the steps to completing the assignments? Where do you start from? Well, step number 1 is getting started, which is exactly what you're doing right now. So listening to the instructions, or you may choose to read the assignment from beginning to end. Step 2, log on to your Desmos class. Remember, you must sign in to Desmos using the TDSB credentials. To do this, first, you will have to click on Student Desmos. The link is provided for you. Once you click on Student Desmos, it will prompt you to enter your code. This will be a code provided to you by your teacher. And for the purpose of demonstration, I will be entering the code described in here, 8F64AK. Sorry. Once you type the code, the join button is activated, so you can click on it. And if you already have a Desmos account, you can enter your email and your password and sign in. If you don't have a Desmos account, no problem. You can create one by clicking on Create Account, which is right next to the left of the Sign In button. That will prompt you to enter your email. Remember to use your TDSB email account and your first and last name. And I know that very often we are tempted to be very creative with first and last name in such applications, but I encourage you to use your real first and last name. And then you can enter your password. You can use a computer-generated password or your own password. And once you enter your password, you will be ready to create an account. This will take you to your Desmos class. In Desmos class, you will see the assignment and the workspace for you. And we will have access, both you and I will have access to your assignment. In step 3, you will start designing, and this is the most laborious and the longest part of your assignment. You want to start off by creating folders for each function that you are creating. You must create 10 folders, one for each function, and then one folder for the summary of functions, one folder for the sliders. This will help you animate your design. One folder for the shades. And this will make your design more appealing. So you can color parts of the shape. Now, in total, then, you will have to create about 13 folders. It is best to organize your working folders so that you can save it more easily and relocate your functions more easily. Now, when you are starting your design, you may want to use or choose to start off with a rough sketch, and a space is provided for you in your design. And you have to follow on the how-to tutorials links, so these links, in order to help you or to support you with the process of how to do or how to complete each step in the process of designing your object. Last, you have to complete the summary table, which is on the next page. The summary table has 1, 2, 3, 4 questions. So in here, what you have to do is write the equation for the sum or difference of two functions. You may choose either or, a product of two functions, a quotient of two functions, and a composite function. For the first one, you will have to find the local max and local min. You have to show calculations in the space provided. Please remember to disregard the Desmos restrictions when you are completing your calculations. What that means is that when you create your design, you will have to limit the domain of the functions used for the purpose of creating an appealing and beautiful design. However, when it comes to finding the local min and max, you may not be able to see the local min and max. For example, you may only see a part of the graph. You have only used a section of the graph that doesn't necessarily incorporate or include the min or the max. So when you are trying to find the min or the max of the sum or difference of two functions, you have to disregard the Desmos and the restrictions and use the equation as is. The product of two functions, you have to find the x-intercepts. For the quotient, you have to find the domain and range and asymptotes. And for the composite function, you have to find the instantaneous rate of change at some point A that you may choose. In the last step, once you have completed your design and your summary table, you can submit your work. There are two things you need to submit. Number 1, the Desmos link, and number 2, the summary table. Please attach the rubric to the summary table and make it into one PDF copy. I will provide you the instructions of how to combine all the pages into one PDF file. Next is the rubric. You need to read the rubric carefully in order to understand what the expectations are and how to earn maximum marks. Remember that just like in any math presentation, you need to show your diagram and define variables, state the formulas, show substitution, show your work, state restrictions, state concluding statements, and use correct notation. Remember, no marks will be given if you use differentiation and integration in your calculations, because these are calculus concepts that can easily answer the questions described in the summary table, but they are not taught in the advanced functions course. As you can see, the rubric is divided into 5 levels: 0, 1, 2, 3, and 4. And there are 5 components we look into. So 1, 2, 3, 4, and 5. Each component is worth a maximum of 4 marks, and you probably want to focus on level 4. In the last page, we have reserved this for the frequently asked questions. Please read through the questions, and I hope that you find the frequently asked questions answers useful, and I hope you found the instructions of this video helpful. I wish you have fun with this activity, and I wish you have fun with your design and find a happy way to express yourself through it. I'm looking forward to seeing all your work, and thank you for listening. See you next time.